Okay, welcome back. So today we're going to do some data augmentation to solve our problem with overfitting. And how's that going to work? Well, imagine I have an image of a letter A, for example. So here's my image. It's got maybe a letter A on it. There's a lot of things we can do to take this image, change it, and use that as additional data. So we'll be adding new information to the model even though we don't have a new image. One thing that we could do is we could flip this upside down. That would teach the model that even though this thing's upside down, it's still an A. We could flip it 45 degrees, still an A. We could make it really small. We could make it really big. We can even, obviously we could change colors. It's still going to be a letter A. We could even have an image like this where maybe the left part of it got chopped off a bit, but we still recognize that as a letter A, kind of like a crop operation. So there's lots of different things that we can do by taking an original image, modifying it, and then using that as additional data. And there's even the option of randomly not including images in our data set so that we randomly drop images out. So these are all different types of operations that we're going to do right now. So jump back into our model, and what's nice about Keras is all of these operations, or I should say most of these operations, are used in the model layers. Very easy to implement. And we are already using a augmentation already. It's the rescale augmentation. Now what we could have done is when we first went through this data set, we could have rescaled all those images with a different library using NumPy, or we could have rescaled them using OpenCV. But we actually used a augmentation layer, which takes the original image and scales it down. So that's an example of augmentation that we've already implemented. So now we're going to add additional layers. They're going to perform additional random augmentations. And then those will feed into our model. And that will hopefully give us a much better result. So we'll retrain our whole model, and we will check the result again. So let's add some augmentation layers. So the first layer we're going to add is a random flip. Very self-explanatory. It's going to randomly flip the image. Now what we could do is we could set the mode as horizontal, so it just flips horizontally. This would be useful if a vertical flip would render your classification invalid. So for example, if you were trying to classify things as upright or not upright, maybe you're trying to classify things as good or bad in an assembly line, and you want to capture things that are only standing upright, you wouldn't want to flip things randomly vertically, because if you did, it would confuse the model, since the vertical orientation is related to the object of whether it classifies or not. But in our case, it doesn't matter. If we take a flower and flip it upside down, or flip it vertically or horizontally, it's still going to be a flower. So we can use the horizontal and vertical flipping. The seed, just like other things, that's going to be our random number generator seed. That's useful if we are trying to do exactly the same thing. If I'm trying to programming it and you guys are programming it and you want to see, do we get the exact same results? We could all use the same seed numbers. That would force all the RNG to be the same. And even though the numbers are a random distribution, the distribution represents a random set. It's not truly random. We could actually reproduce that over and over again. So anyways, that's going to be pretty much common theme throughout all these operations. So that's the random flip layer. So let's feed in the input shape equals shape. It's good to put the shapes on these layers. All right, so it's as simple as that. That's our random flip. So next we want to do a random rotation. Very self-explanatory. Oops. All right, there we go. So random rotation. So we'll do random rotation. And same thing, I'm going to put in an input shape equals shape. Okay, next let's add, oh sorry, we've got to go back. So we have to put in a factor here. It's good to put in a factor. So let me delete this so I can get the IntelliSense back. Yeah, so the factor you can think of as kind of a ratio from 0 to 1. It's a float value from 0 to 1, and it's going to be kind of a amount of rotation. So if you set this to a very large number, you're going to get much bigger rotations. So this is good to control. Again, if you had things that where, for example, if they were rotated so much that they failed to stay what they were originally intended to be, you wouldn't want to set the rotation value very high. It will confuse the model. But in our case, if you take a flower and rotate it around, it's still a flower. But there are other examples of things where you might have, again, you might have an example of an assembly line, and you want to confirm that the products are standing in the right orientation. If you rotate them all around, it's going to confuse the model. So in our case, let's set the rotating factor as 0.3. And again, let's put in our input shape equals shape. Okay. Next, we're going to do a random a zoom layer. So we'll say layers dot random zoom. And again, we're going to have a zoom factor here, similar type of situation. So let's just set these to all to like 30% or 0.3, however you want to think of it. And again, let's put in our input shape. And just as a reminder, the input shape is the shape of our input data, which is a 180 by 180 by 3, because it's a 3 channel image, R, G, and B. Okay. Next, we want to do brightness, so we can say layers is random brightness. So this is very good. So recently, I did a World of Warcraft phishing bot a while ago, and this is an example where if we were training this to be a phishing bot, different zones have different ambiance. You know, the lighting is bright in some areas, sometimes it's dark. So this is going to make our model more robust for different lighting conditions and different, you know, colorizations, which is going to be very important for our flower model. So let's set this also to 0.3. And again, we'll put in our input shape. And let's do a contrast. I won't explain that. It's similar as the brightness, except it'll be adjusting the contrast. So we'll say random contrast, and we'll put in, let's do 0.3. I did this model a while ago, and I forgot what I used. I think I used something around 0.3. Okay. And then we want to have the dropout layer. So we'll say layers dot dropout. And again, we're going to put in a dropout factor. It's you can kind of think of it as a percentage, or, you know, a factor of how often images are going to be dropped out. So we'll set that pretty high as well. And let's put in input shape equals shape. Okay. Now, if you're wondering why do I like putting input shape equals shape, even though probably technically I could just do it on the first one, what I like to do is sometimes if I want to drop a couple of layers out, I can do this, and I know it's not going to break the model. I don't have to go in there and start toying around with it. So it's nice to be able to enable and disable layers quickly. That's why I do it out of habit, but you don't have to. It's kind of optional. So I think that's it. So we can probably go ahead and retrain this, which I'll break this up into another video. We'll retrain it in the next video, and we'll compare the results. But this is essentially now a improved version of our model, where instead of just running the data through, we are now augmenting our data through flips, rotations, zooms, brightness, contrast. There are other augmentations that we could do. You can probably start using your imagination. But this is a great introduction, and it shows you how simple it is to add augmentation layers to the Keras framework. So I'm going to save this, and I am going to generate this model in the next video, and then we'll test it. So see you in the next video.